We'll study today the fifth FRQ from 2015. I called it Graph of Derivative to correspond with the FRQ by genres that you can find on Schoology. It's a non-calculator exercise, one of the 4 non-calculator problems, and the mean for this exercise is right on par with the mean of the entire FRQ section. Most students presented work in all parts. However, 17% of students earned no point. So we'll read the question. Notice from the beginning that this is the graph of f prime, hence the title, Graph of Derivative. The figure shows the graph of f prime, the derivative of a twice differentiable function f on the interval -3, 4. The graph of f prime has horizontal tangents at x equals -1, x equals 1, and x equals 3. That feels maybe unnecessary for you, but it's just confirming that these horizontal tangent lines are exactly where they seem to be. So it's at x equals -1, x equals 1, and x equals 3. Let's continue. The area of the regions bounded by the x-axis and the graph of f prime on the intervals -2, 1 and 1, 4 are 9 and 12 respectively. So the area is 9, the area is 12, but of course the integral from -2 to 1 is -9, the integral from 1 to 4 is -12. So let's start immediately with question A. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. Student A says f has a relative maximum at x equals -2 because f prime switches from positive to negative at this point. That's perfectly correct. So we have here the graph of f prime, it's positive and then it's negative. So at x equals -2 it changes sign. So the student earned 2 points, one for identifying the correct value of x and one for giving a reason. Now there are other places where f prime is 0, here and there, so you have to be careful. It's not enough if f prime of x equals 0, it has to change from positive to negative. One more comment, this sign here, in my opinion, means therefore, so I think it's incorrect to have this sign here. The student could have written f prime of x switches from positive to negative at this point, therefore f of x has a relative maximum at x equals -2. But the way it's written here, in my opinion, is incorrect. The second student, before we see the work, I wanted to show that you'll always have the graph repeated. You have the question and the graph is presented, just like here at the top, and then in the section where you have to write your answer, the graph will be copied again, so you can sketch stuff on the graph, you can take notes. The student here wrote a 9 and a 12, so you'll have the graph just like you have the graph if you need to do, for example, a slope field and stuff like that. Usually graphs and tables are repeated in the answer on the answer sheet. The student said at x equals -2, f has a relative max because this is where f prime of x changes from positive to negative. So 2 points. I showed this because the student really circled f prime many times just to remind themselves that this is not the graph of f, and I think it's a good idea. Our third student said f has a relative maximum at x at point -2 because the graph of f prime at -2 goes from positive to negative. This is correct again. We could argue that -2 is not a point, but it's fine. It earned the credits. So 2 points for every single student here. In question B, let's read the question first. On what open intervals contained in -3, 4 is the graph of f both concave down and decreasing? Give a reason for your answer. We'll have to be careful and write open intervals, not closed intervals, because they are requiring this here. So there's two things. F is concave down and f is decreasing. f is concave down, we know when f double prime is negative. How are we going to see that on the graph of f prime, though? We have to think in terms of this is the first derivative of the graph here. So if this graph is decreasing, that'll be f double prime is negative. So this is the first part. We're going to have to look where this graph is decreasing. The second part of the question is where is f decreasing, and that happens when f prime is negative. So now we can combine these two informations together. Where on the graph of f prime can we see a decreasing curve and the curve on the negative side of the x-axis? There's this little part here, and there's this part here. So we'll see what student said. The graph of f is both concave down and decreasing on the intervals -2, -1, and 1, 3, because on these intervals f prime is negative and also f double prime is negative. The student earned 2 points here, 1 for identifying the intervals and 1 for giving a reason. So write sentences when you give reasons in AP Calculus AB. And your sentences need to use some calculus concept. So here f prime, f double prime. The second student said the intervals are -2 and -2 to -1 and 1 to 3, because this is where f prime of x is negative and the slope of f prime of x is negative. Again, the intervals are correct, that's 1 point, and the reason given is correct, 1 point. The third student said it is concave down at point -2 because it has a relative maximum at that point. So the question asked for interval, for an interval or for intervals. So if your answer gives a single point, it's probably not going to be correct. Maybe at the point -2, x equals -2, it's concave down, but it's not going to answer the question. So 0 points here. Question C. Find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. So one of these things you need to really be comfortable with. F has a point of inflection if and only if f double prime changes sign. The first student identifies 3 points: x equals -1, x equals 1, and x equals 3. The x-coordinates of the points of inflection for the graph of f are x equals -1, x equals 1, x equals 3. This is because at these points f double prime of x switches sign. It's correct. On the graph of f prime we see this is decreasing then increasing, so f double prime will switch from negative to positive. Here it's increasing then decreasing, and then it's decreasing then increasing. So that corresponds for f double prime to f double prime is negative, positive, negative, positive. 2 points, 1 for identifying the 3 x-coordinates that we are asked for, and 1 point for a reason. The second students find the same point, and that gave the student 1 point for x equals -1, x equals 1, x equals 3. However, the justification isn't enough. The student says this is where f prime of x has a slope of 0. But if f prime of x has a slope of 0, it doesn't necessarily mean that f double prime will change sign. I think, yeah. So we have to be careful. It's not enough if f prime of x equals 0. I'll talk about that again at the end in the recommendations. The last student said it has a point of inflection at point 1, and we won't read the rest because I think the student was a little bit confused, but this is not the correct answer. Question D. Until now we haven't used the information that the area here is 9 and the area here is 12, so it's obviously going to come up in question D. Given that f of 1 equals 3, write an expression for f of x that involves an integral. Find f of 4 and find f of negative 2. So the student writes this: f of x equals the integral from 1 to x of f prime of t dt plus 3. The student showed no work. If you study some FRQ answers from AP Central, you'll see that they don't show work either. They just set things up like that. But I want to show you how this comes to be, and maybe you'll be comfortable in just setting it up like this right away, but I want to show you where it comes from. It all comes from the fundamental theorem of calculus. If you integrate a function from a to b, the result is capital F of b minus capital F of a. If I change f here, which could be any function, to f prime, then the same fundamental theorem of calculus is going to tell us that the integral from a to b of f prime of t is f of b minus f of a. I just went one level lower. Instead of having f and its integral, I have the derivative of f and f. Now, in this problem, it's not a and b, it's 1 and x. So in this particular case, it's going to be f of x minus f of 1. If I continue from here, I can substitute f of 1 because f of 1 is given. F of 1 is equal to 3. So the integral from 1 to x of f prime of t dt equals f of x minus 3. And finally, if we add 3 to both sides, we find f of x equals the integral of f prime of t dt plus 3. So this is how the student got this value, or this expression here. So let's see how the student worked from here. Given that f of x equals 3 plus the integral, if we are looking for f of 4, we'll just substitute 4 here, and we now have the integral from 1 to 4 of f prime of t dt, which really is the signed area. So we are integrating from 1 to 4. It's exactly the signed area here. The area is 12, the signed area is negative 12 because we're below the x-axis, and therefore the student gets negative 12 plus 3 equals negative 9. Then for f of negative 2, same idea, we substitute x with negative 2, so we are integrating from 1 to negative 2. The integral from 1 to negative 2, it's going backwards, so it's going to change the sign again. So the area is 9, the signed area is negative 9, but since we're integrating backwards, it becomes positive 9 again, and the result is 9 plus 3 equals 12. The student always puts boxes around their answers. It's a great idea. Especially if your work is a bit of a mess, just box your answers every time. The FRQ evaluators are always going to look in two places for your answer. They're going to look at the bottom and they're going to look inside the box. It's a really good habit to box your answers. There were lots of points here. 1 point was earned just for stating that the integrand was f prime of t. 1 point was earned for the entire expression of f of x, and that means remembering that we have an initial condition here, so plus 3, and also for writing it correctly in math. If you forget the dt here, often it doesn't matter, but the way the student wrote it, if you wrote integral of 1 of x integral from 1 to x of f prime of t plus 3, then this expression is really wrong mathematically. So be careful, put the dt so that you don't make a small mistake. You would avoid this issue if you would write f of x equals 3 plus and then the integral. Finally, there was 1 point for the answers, so a lot of work just for 1 extra point. If you make a stupid mistake, you lose the point. The second student wrote this: f of x equals the integral of f prime of x dx, and forgot the initial condition. So there should be 3 plus this integral. Therefore, the answers here are going to be wrong, and that student only earned 1 point for stating that it's the integral of f prime of x dx, but lost the point for f of x being correct, and then could not earn the points for the values f of -2 and f of 4. Our last student also earned 1 point. We can see here that they wrote the integral of f prime of x dx. This line is perfectly correct. However, they only earned 1 point in this exercise. It's a little bit cruel, but the reason is they got 1 point for getting the integral of f prime, but they never write any expression for f of x. There's no general expression for f of x. The student jumped right to the conclusion f of 4 equals. So there is no f of x written anywhere. And then the student doesn't write an answer, so probably they didn't really know how to find that integral. They didn't figure out how to use the 9 and the 12. So there was only 1 point earned by this student. So some common mistakes. In part A, some students presented vague language. When you give a reason, you have to be clear, you have to use calculus, you have to write sentences. Graphs or tables are not enough. In part B, many students simply presented the incorrect intervals, omitted an interval, or struggled to express their reasons. In part C, many could not present an acceptable reason. Many argued that horizontal tangents or that f double prime of x equals 0 justify points of inflection. Let's see a very basic example. So there's a point of inflection if f double prime changes sign. It could be 0 at that point, but it doesn't change sign. It was negative, then it's 0, and then it's negative again, so it didn't change sign. Even simpler is the line here, f of x equals 3 over 2x minus 1. The derivative is f prime of x equals 3 over 2. The second derivative is 0. For any point, the second derivative is 0. However, we would never say that a line has points of inflections everywhere. It doesn't turn at all. There were many vague references to the slope of the slope or the derivative. When we juggle with many functions, either a function f and a function g, or here f, f prime, f double prime, you really need to say what you're talking about. You can't just say the slope. You have to say it's the slope of f prime that I'm talking about. Is it the slope of f? Is it the slope of g? Just say it. If there's only one function, it's not going to be a problem. But if we have several functions or graphs, then we have to say what we're talking about. In part D, many students were able to earn the conceptual point for having f prime of x as the integrand in a definite integral. We just saw that it was true for our 3 students. However, few students provided an expression for f of x. Many students were unable to work with regions below the x-axis and limits of integration in which the lower limit is greater than the upper limit. In part D, the most common errors were failure to provide an expression for f of x, failure to incorporate the initial condition, that's the plus 3, mishandling the area of a region below the x-axis, and inability to evaluate when we are going backward from 1 to -2. So we saw all these mistakes in the student's work. We also saw a first student who did everything right. Recommendations: teachers should emphasize the importance of clear, concise language when providing a reason for an answer. Standard notation and symbols should be used in these reasons. Teachers and students should avoid using non-standard notations or shorthand. For example, we do not read f like this as f is increasing. Also, students must be specific in references to a derivative, slope, or graph. Students should use standard notation for derivatives, f prime of x and f double prime of x, rather than the phrases, the first derivative or the second derivative. It is important for students to refer to specific functions by their names. Alright, maybe one more thing that we have to be careful of: the derivative, the slope, not saying the slope is increasing when we actually mean the function is increasing. If the function is increasing, then the slope is positive. small things like that. All right, thank you very much for listening.